Welcome to Developer Service YouTube channel. On today's video, we're going to be predicting the weather with machine learning algorithms and the historical weather data from Open-Meteo. We're going to be evaluating different modules and checking their error rate. And we're going to be predicting the temperature, retrieving the actual temperature, and of course, understanding what was the prediction error of those algorithms. On the previous episode, we predicted the weather with the Zambretti algorithm. So if you want, you can also take a look at that video. But for today's video, let's now take a look at how we build the code. Before we start, just a quick introduction to Open-Meteo. Open-Meteo is an open source weather API that offers free access for non-commercial use, so no API key is actually required. They provide several APIs, but for this concrete use case, we want the historical weather API, which allows us to retrieve data from 10 years or 15 years or 5 years ago. We can test the API in this page. Like I mentioned, no API key is necessary. And if you click the example, you can see it gets JSON data even without an API key. So we're going to be using the archive API to get the data. And of course, we need to use Scikit-Learn for machine learning in Python. And we're going to be using that for the machine learning algorithms that we're going to be trying in our code. So those are the two components that we're going to need in this project. So in terms of packages, we're going to be needing to install requests for the request to the Open-Meteo API, pandas to transform the JSON into a data frame, and the Scikit-Learn so that we can use the machine learning algorithms as we just saw. And now let's finally take a look at the code. So first we start with our imports. Of course, we need to import requests, we import pandas, we import several libraries from the Scikit-Learn library, and of course we import datetime so that we can use the current date. So we first start by fetching the historical data from the Open-Meteo API. We'll be using the archive API endpoint. We're going to be passing in a series of parameters, the latitude and longitude, in this case for Berlin, the start date, which is going to be for us 2013, and the date 2023. So we're going to be getting 10 years worth of data. We are interested in the temperature and the precipitation, and we're interested in the hourly values of those. And of course, we specify the time zone, Europe, Berlin. We do a get request with that URL and the parameters we specified. That returns us a JSON response, which you store in the data variable, and we convert that JSON to a data frame. We're interested in storing a datetime key, which corresponds to the time, the temperature, which corresponds to the temperature value, and the precipitation, which corresponds to the precipitation. All of this from the hourly key from the API as we requested in the API endpoint. So next we are going to be training and evaluating our machine learning models. So first we start by defining that the datetime is the index of the data frame. We start by doing the feature engineering, meaning selecting the fields that we are interested in using in the machine learning modules as characteristics that we want to use for understanding the values and making the predictions. So we're interested in the hour, the day of the year, so if it's a Monday, Tuesday, or Wednesday, or any of the other days, and in the particular month. So given the combination of the month, the day of the year, and the hour, then we can establish a set of characteristics that allow us to train the machine learning model. So of course, that means that we are defining the features, like I mentioned. So hour, day of year, month. We also use the precipitation. That is for our x values, and our y values is the temperature. So meaning that we want to combine all these features into one single target, which is the temperature value. That's our target by using all these features. So we want to establish the relationship between the temperature and all these different features, and that's what will help the machine learning algorithm learn and predict the weather. So we split the data into training and testing sets as per standard. So we have one for the X features and one for the target, the train and test. And we split so obviously the X and the Y, which was defined before, in terms of the features and targets. The test size is 0.2, so that means that the values for testing, or the sample is for testing, is 20% of the total data that we have. And we provide a random value just so that it selects randomly which is the test and the training data. We define a list of models that we are going to be training and checking their accuracy. So we use the random forest regression. We will use the gradient boosting regressor also, each one with 100 estimators. Again, we do pass a random state in terms of the use, and we're going to be also be testing out the linear regression model. Now that we defined our models and our data, we can train and evaluate the models. So for each of the models, we're going to be fitting the model, meaning starting training the model. We're going to be doing the prediction, and from that prediction, we do from the test date and the actual prediction, we're going to be achieving the mean absolute error, and those we store in the results variable. And this mean absolute error would give us an indication of which of the best models we can choose, and the best model will be the one, of course, with a lower mean absolute error rate. So after we test and evaluate the models, we're going to be selecting the best model. As I mentioned, the best model is going to be the one from all the results that has the lowest mean absolute error rate, and then we're just printing out what is the best model, and that's how we train and evaluate the models. Now that we have selected the best model, we're going to be making a prediction for a future date, meaning a date that is not in the model itself. In this case, we're going to be using today's date, which is 2025 February, and the day is 21. So we're going to be specifying the future features that we want for this date, and we want the hour at noon. We want the day of the year, like before. We want the month, and we want the precipitation. In this case, we're going to be assuming that the precipitation is 0, using that as a default. Then we're going to be, from the best model, we're going to predict with these features. It will give us a prediction, and we're printing out that prediction in terms of which will be the predicted temperature for this particular date. Now that we have the prediction, we're going to be retrieving the actual temperature for comparison. For that, we're going to be using the Open-Meteo standard API, the forecast API, passing the latitude and longitude again as parameters. We're again interested in the hourly temperature, time zone here Berlin, and start date and end date is the current date that we are interested in analyzing, which was the date for which we did the prediction. We do a GET request from the URL with the parameters, and this will give us a JSON response that we'll be converting into the actual data variable. We're going to be checking if we have the hourly temperature, for that output. So the JSON response contains actually that temperature that we require for that day. And if we do, then we extracted that noon temperature into the actual temperature variable. We print the actual temperature, and then we print the prediction error, which is the difference, of course, between the actual temperature and the future temperature, which is in terms of the absolute value, so no minus or plus, just the absolute value. And we print that to the console, or if the data is not yet available for comparison, we also print that. So we're now ready to run the code, and we are running the code, and it will take a while to download the data and to evaluate each of the models, and then picking the best model, and then it will do the prediction, and finally it will show the output of the prediction result. So with the magic of filmmaking, we're going to be fast forwarding this a little bit, and I'll see you once it has finished processing. As you can see, it has finished. So first we got the historical data, then we train and evaluate the 3 different models. Random forest has an error rate of 3.1 degrees Celsius, the gradient boosting 2.87, the linear regression 6.59. So of course the best model is the gradient boosting, which is 2.87. Then we make the prediction. The predicted temperature for the 21st of February 2025 was 6 degrees 29. We retrieved the actual temperature, and the actual temperature was 5 degrees 80. So the prediction error was 0.49 degrees Celsius, so half a degree the error of the prediction, so very good prediction. And that is it. That is all that is required to predict the weather with machine learning algorithms and Open-Meteo weather data. Like this video if you liked this content. Subscribe for more content about Python, Django and AI. And until next time, happy coding!